Good day, students. How are you doing? I hope you have been keeping safe and you have been making efforts to study your books. This is your chemistry teacher, Miss Adana Ogu. Today I'll be teaching a topic in chemistry for SS1. I need to quickly mention here that the note for this topic that I'm treating has been sent to the school website. I hope you've gone there to make the effort to copy the note. So in this video, I'll be treating the topic for week 1 and week 2 because the topic covers is on acid, so I need to bring it together and treat it in this video. So there are specific things you are supposed to learn at the end of this class. So let's look at those things you are supposed to learn. The topic is acid, and at the end of the class, you should be able to learn various things. One, you should be able to define acid. Two, you should be able to state the classes of acid with examples, differentiate between strong and weak acid, concentrated and dilute acid. That means you should be able to understand the concept of strong and weak acid and differentiate them, also concentrated and dilute acid. Then next, you should be able to identify the basicity of any given acid. Next, you should be able to state the physical and chemical properties of acid, and then you should be able to mention the uses of acid. Now, definition of acid. I'm sure acid is not a strange word to you. You have one time or the other heard about acid, and most of the time we think of it as a substance that has the ability to destroy things. But on the contrary, acid has useful role they play. For example, in the stomach, we have hydrochloric acid, which aids in food digestion. So let's quickly define what an acid is. An acid is a substance which, when dissolved in water, produces hydrozonium ion. Now, yes, this is hydrozonium ion, H3O plus, which produces hydrozonium ion when dissolved in water as the only positive ion. I'll say that again. An acid is a substance which, when dissolved in water, produces hydrozonium ion as the only positive ion. Now, look at this H plus. Why is this H plus here and why is it before the hydrozonium ion? It is important for you to note that an acid will always ionize to produce hydrogen ion. That's the characteristic property of an acid, production of hydrogen ion, which combines with water molecule to give you hydrozonium ion. So that's why the definition of an acid is a substance which, when dissolved in water, produces hydrozonium ion as the only positive ion. Now let's look at specific examples. Remember I told you that an acid will ionize to give you hydrozonium ion. Now look at this. This is HCl. HCl is an acid, hydrochloric acid. So it will ionize to give you hydrogen ion and Cl minus. Now this hydrogen ion is what combines with water. Now, did you see this reaction now? This H plus from the acid, hydrochloric acid, combines with water molecule, which it is dissolving, to give you H3O plus hydrozonium ion. Now, next, I'll show you the overall reaction. The overall reaction is that hydrochloric acid, which is this, combined with water to give you hydrozonium ion, or what is called ozonium ion in some textbooks. Hydrozonium ion and Cl minus. This is the overall reaction. An acid dissolved in water give you hydrozonium ion as the only positive ion. Did you get that now? So an acid is a substance which, when dissolved in water, produces hydrozonium ion as the only positive ion. Now look at another example. This is H2SO4 tetraoxosulfate 6 acid in water. We give you hydrozonium ion. Now this H2SO4 ionized to produce two hydrogen atoms, which combines with water molecule to give you hydrozonium ion. Then you have your anion. So the only positive ion is H2. SO4. So an acid is a substance which, when dissolved in water, produces hydrozonium ion as the only positive ion. That's the definition. Now let's look at the classification of acid. Acid can be classified into organic and inorganic acid. Organic acid are those acids that are found in natural products, like you have ethanol in ethanoic acid in vinegar, citric acid in lemon and lime, ascorbic acid in oranges, lactic acid in milk, tartaric acid in grapes. I gave you quite a number of examples in your notes. Go there and you see them. Then inorganic acid are those acids that can be synthesized from inorganic matter. They are synthesized in the lab, e.g. hydrochloric acid, tetraoxosulfacic acid, tetraoxophosphate 5 acid, thiazocarbonate 5 acid. These are examples of acid. I gave you quite a number. Nitric acid, which is also thiazonitrate 5 acid. These are examples of inorganic acid, those acids that are synthesized in the laboratory, while organic are those ones that are found naturally in products. Now, next, we look at strong and weak acid. Now, when you hear the word strong and weak, we are looking at the strength of something. So what determines the strength of an acid is its ionization power, its ability to ionize, whether completely or partially in solution. So an acid which ionizes completely in solution is known as a strong acid. So when it is in solution, it ionizes completely in solution, while a weak acid will ionize partially in solution. Now, examples of strong acid are hydrochloric acid, thiazonitrate 5 acid, tetraoxosulfacic acid. These three, hydrochloric acid, thiazonitrate 5 acid, and tetraoxosulfacic acid, are examples of strong acid. Then weak acid that I said ionizes partially in solution. Examples are all organic acid, those acids that are found in natural products. They are all weak acid. Then other inorganic acids that are weak are thiazonitrate 5 acid, tetraoxophosphate 6 acid. These are examples of weak acid. So in nature, organic acids are weak, while these thiazocarbonate 5 acid and phosphoric acid are weak acid, while these three, hydrochloric acid, thiazonitrate 5 acid, and tetraoxosulfacic acid, are strong acid. Now, next, let's look at concentrated and dilute acid. Now, concentrated and dilute acid has to do with the amount of acid contained in a solution. So when you have a solution of acid, it is either concentrated or dilute depending on the amount of that acid contained in that solution. So a concentrated acid contains relatively large amount of acid in solution, while a dilute acid contains a relatively small amount in solution. Now, let's take an example. In chemistry, concentration is measured by mole per dmq. That's the SI unit of concentration. So look at this example. I have 10 mole per dmq. And then look at another example. I have 1.0 mole per dmq, 1.0 mole per dmq. You agree with me that 1.0 mole is smaller. That means the amount of the acid in this 1 dm cube of solution is small, compared to 10 mole is large. 10 mole per 1 dm cube. So we say that 10 mole per 1 dm cube is concentrated, while 1.0 mole per dm cube is dilute. Now let's look at another example in terms of mass, and then look at these two examples that I have here. 98 gram per 100 cm cube. Now, and then 98 gram per 1000 cm cube. The same mass but different volume. So there is relatively large amount of the acid in a little amount of the solution. While you have relatively large amount of the acid, let's use the large amount, but in a large volume of water. So this becomes dilute, and why this is concentrated. I hope you understand. So concentrated means large amount of acid in small amount of solution. Let's use it in a layman's language. Relatively large amount of the acid in a small amount of solution. Why dilute means relatively low amount of the acid in a large amount of solution. So that's what we mean by concentrated and dilute acid. Now I need to mention here that a strong acid will be a strong acid whether it is concentrated or dilute, while a weak acid will always be a weak acid whether it's concentrated or dilute. Meaning that H2SO4, if you have 10 mole per dm cube of H2SO4, it is concentrated, while 1.0 mole per dm cube of H2SO4 is a dilute strong acid. But if I have 10 mole per dm cube of thiazocarbonate 5 acid, it is concentrated form of the weak acid, while 1.0 mole per dm cube is a dilute form of the weak acid, thiazocarbonate 5 acid. I hope we are getting this. So next, let's look at basicity of acid. Now, the definition of basicity means number of replaceable hydrogen atoms in the molecule of an acid. Now, remember when I was explaining the definition of acid, I said that an acid will ionize to produce hydrogen ion, which now combines with water molecule to give you the ozonium ion. Now, the number of replaceable hydrogen atoms in the molecule of an acid is referred to as basicity. Now, let's look at the example. Hydrochloric acid, we ionize to give you H plus, just one hydrogen ion. So we say that it is monobasic. Next one, tetraoxosulfate acid is diabasic because it will produce two hydrogen ions. That's why it is known as a diabasic acid. Then next one, we have H3PO for tetraoxophosphate 5 acid. We ionize to give you 3 hydrogen ion and the anion. So that's why it is known as tribasic ion, tribasic acid, sorry. That's why it is a tribasic acid. Then lastly, let's look at this example. CH3COOH, this is ethanoic acid. Now, ethanoic acid, the only ionizable hydrogen in this ethanoic acid is this one. That's why it is producing one. It has four hydrogen atoms. That's 3 here and 1 here. That's making it 4. But only one out of the 4 it can be ionized. So, and that is the one that can be replaced. So we refer to ethanoic acid as monobasic. So that goes to show that it's not all the hydrogen in an acid that can be replaced. So the one that is replaceable is known as its basicity. So that's why ethanoic acid is a monobasic acid. Hope you understand it. Basicity is the number of replaceable hydrogen atoms in the molecule of an acid. For hydrochloric acid, it has 1 hydrogen and it is replaceable. In tetraoxosulfate acid, it has 2 hydrogen and it is replaceable. In phosphoric acid, that's tetraoxophosphate acid, it has 3 hydrogen and it is replaceable. Then in ethanoic acid, it has 4 hydrogen, but only 1 is replaceable. That's why it is referred to as a monobasic acid. While HCl is monobasic, tetraoxosulfate is dibasic, thiazonitrate 5 is tribasic, while ethanoic acid is monobasic. Now moving on, we go to the next one, which are the physical properties of acid. Physical properties has to do with things that has to do with feelings, taste, touch, and the things you see with your 5 senses. Now let's look at one. Acids have sour taste. Look at this example, lemon and lime. I'm sure one time or the other use lemon and lime. When we take it, we feel this sour taste in our mouth, very sharp taste. So that's as a result of the citric acid contained in lemon and lime. So all acid have sour taste. Then, but when you get to the lab, you don't taste things like that. So, but in natural products, we can relate with it that acid actually have sour taste. So acid, one of the physical properties of acid is that they have sour taste. Next, acid turn blue litmus to red. Now, A litmus paper or litmus is an indicator, something that helps to know what a substance is. So in the laboratory, we have what is known as litmus paper. So when you dip a blue litmus paper inside a beaker containing an acid, it will turn it red. So for example, you get to the laboratory now and you see a substance. You don't know what it is. Probably there was a mistake, it was not labeled. And you dip a blue litmus paper inside that solution. Once the solution turns to red, or once the solution turns that litmus paper, which is blue to red, we know that that is an acid. So an acid turns blue litmus to red. Now, another physical property of an acid is that the concentrated form of strong acids are corrosive. Now, remember I talked about concentrated, strong, and weak acid. So the concentrated form of a strong acid, like concentrated form of H2SO4, concentrated form of triazonitrate 5 acid, concentrated form of hydrochloric acid are corrosive. Now, look at this towel. This is a towel that was corroded by a few drops of acid. So, like when we say burnt by drop of acid. So this is known as the action of a concentrated strong acid. So concentrated form of strong acid are corrosive. Now, I'm sure you've heard of stories or situation where someone was poured acid and the person got burnt. That is corrosion of the person's skin. So the concentrated form of strong acid, we cause corrosion. That is like burning, like what we are seeing in this diagram. Now let's look at the chemical property of acid. That is, how do they behave chemically? Number one, acids react with active metals. When we say active metals, those are metals that are more electropositive than hydrogen itself. So when an acid reacts with such active metal, it will give off hydrogen gas. Now, active metals are, let me give you an example of active metals: sodium, potassium, calcium, magnesium, zinc, iron. These are examples of active metal. Now, look at this example that I gave. This is hydrochloric acid, an acid reacting with magnesium, Mg, to give you NgCl2 and give off hydrogen gas. So if, for example, another acid like H2SO4 should react with, let's say, sodium, it will give a salt and give off hydrogen gas. So one of the chemical properties of acid, that it reacts with metals to give off hydrogen gas. Then next, neutralization reaction. Neutralization reaction is the reaction between an acid and a base to give you salt and water only. So neutralization reaction is a very important reaction in chemistry. So I told you it's the reaction between an acid and a base to give you salt and water. By next week, we'll be treating base. So an acid reacting with a base will give you salt and water only. That is known as neutralization reaction. Now let's look at an example. This is an acid, H2SO4, reacting with a base, calcium oxide. Now, to give you salt, calcium tetraoxosulfate 6, and water, H2O, to give you water. Now, this is a typical neutralization reaction. There are others that I've given to you in your notebook. Please go there and read it up. Then another chemical property of acid, that they react with triazocarbonate 5 and hydrogen triazocarbonate 5 to give off carbon 4 oxide. Now let's look at an example. This is a triazocarbonate 5 reacting with an acid to give you salt, water, and give off carbon 4 oxide. Now when we say the word give off or liberate, it means it goes into air because they are gases. So it will give off CO2, which is carbon 4 oxide. Now, another example is, now before I give the other example, this is calcium triazocarbonate 5, a triazocarbonate. Why? Look at this, sodium hydrogen triazocarbonate. This is a hydrogen triazocarbonate compound. So reacting with an acid, HCl, to give you sodium chloride, water, and give off CO2. So in any reaction between an acid and a triazole and hydrogen triazole, it will give off CO2 triazole as the product. So that is on the chemical properties of acid. Then now, lastly, let's look at the uses of acid. What are the uses of acid? Acids can be used as preservative. For example, acid contains in vinegar are used in preserving food industrially, even at homes. You use it sometimes in preparation of salad to make it look, give it taste, but actually it can also help in preserving that food. Then acid is used in making car battery. For example, tetraoxosulfate acid is used in car batteries. Then it can be used in making dyes, fertilizer, soap, salt, and many industrial products. Acids are also used as catalysts. There are substances that help to alter the rate of reactions. They are used as catalysts, they are used as a drying agent, that means to dry up substance. So those are the uses of acid. Now, I hope you understand. This is where we end the class for today. So I'll quickly recall what we've done. We talked about definition of acid as a substance which produces hydrozonium ion as the only positive ion. And I told you that the characteristic property of an acid is the production of hydrogen ion, which combines with water molecule to give you the hydrozonium ion. Then we talked about strong and weak acids. Strong acids ionizes completely in solution, while weak acids ionize partially. Then concentrated acid are those acids that contain large amount of the acid in solution, while dilute acid are those acids that contain small amount of the acid in solution. Then we also went further to talk about basicity, number of replaceable hydrogen atoms in the molecule of an acid. Talked about physical property, they have sour taste, they turn blue litmus red, concentrated form are corrosive. They will talk about chemical properties, neutralization reaction between an acid and a base to give salt and water, reaction between active metal to give up hydrogen gas, then reaction between triazole carbonates and hydrogen triazole carbonate to give off carbon 4 oxide. And then we talked about the uses of acid. So this is where we will end the class for today. I hope we got something. But if you did not understand anything, maybe there's something you were not cleared with, or even while you were copying the note, please reach out to me, send me WhatsApp message, call me, or send me an SMS. I will get back to you as soon as I get your message. You can get my phone number from the school yearbook, or from the school WhatsApp group that was created for all classes. They are right there. So try and reach out to me and ask your question. I'll be very glad to get your question and I will answer you immediately. So this is Miss Adana. Till I come your way next time, I remain your chemistry teacher. Thank you very much for listening. Keep staying safe. Keep studying your book. Thank you very much and God bless you.